Hi, Honors Algebra 2 students. We're in Chapter 6, Day 8 notes. And in this lesson, we're going to give you an introduction to something called a common logarithm and something called a natural logarithm. So for a common log, it has a base 10. So it could be written as log base 10 of x, but usually you'll see it written as just log of x with an implied base 10 in it. There's also something called a natural log, and it has a base of e. And so it could be written as log base e of x, but usually you'll see it written in this format with an ln, which stands for natural logarithm of x. Usually you'll see it written like this. So common log usually is log base 10. Natural log is usually written like this, natural log of x. Before I move on, I want to mention this base of e. So e is a transcendental number. At the beginning of the year, when we talked about classifying numbers into different categories, or in different ways, we talked about transcendental numbers. And one example that was given was pi, and the other example that was given was e. So e is a number kind of like pi. It goes on and on and on. If you were to plug it into your calculator, there is an e button, and it's right below the pi button on your calculator. It actually says it is 2.718281828, and then it keeps going. So that is something that you'll need to familiarize yourself with, not only for this course, but in upcoming courses as well. But that's just a little introduction to what the number e is. And again, the most similar thing you can think about it being like is the number pi. All right, when we simplify expressions that have logs of base 10 or log of base e in them, we're going to do them as follows. If we have log of 10 to the x, keeping in mind there's an implied base 10 right here. So log base 10 of 10 to the x is going to be equal to x, and then natural log of e to the x is also equal to x. And remember, there's an implied e as a base right here. Now the way I like to think about the shortcut is as follows. If the base for the logarithm matches the base that goes with the exponent, the answer is simply the exponent when we evaluate it. Same thing here. If the base right here, which is e, matches the base right here for the exponent, both of them are e's, then the answer is the exponent. And that shortcut is how we're going to evaluate the following examples. When we get done with the examples, I'll go through and talk a little bit about why this works the way it does. And as you're learning more and more things about logarithms in upcoming days, there will be even potentially more and more ways that you could think about why this shortcut works the way it does. In the meantime, though, let's use the shortcut. All right, so in this first example, we have an implied base 10 right here. So the key to using the shortcut is being able to rewrite these so that the argument is also in terms of base 10. So in order to do that, we could write 100 as 10 squared. Now the reason that helps us is because now the base for the log, which is an implied base 10, matches the base that goes with the exponent. So according to what we talked about just a moment ago, our answer will end up being the exponent. And again, we're going to talk a little bit about why that works the way it does. But log of 100 is going to be equal to 2. All right, in the next example, we can rewrite 10,000 as 10 to the 4th. So again, if the log, or the base that goes with the log, matches the base that goes with the exponent, the answer is going to be the exponent. So in this case, it's going to be equal to 4. In the next example, let's write this as log of, that's the 6th root of 10, which could be written as 10 to the 1/6. Again, the base that goes with the log, there's an implied base 10 right here. So that implied base 10 matches this base that goes with the exponent, so the answer is going to be my exponent. In this case, it would be 1/6. All right, in the next example, perhaps we write this as log of 100th. 0.01 is read as 100th. I could write it in fraction form. And then I could rewrite that as log of 10 to the -2. And then we're back to being able to use what we learned at the beginning. If the base of the logarithm matches the base for the exponent, the answer is going to be the exponent, in this case, -2. In these next examples, they have a base e, but we're going to approach them using a similar method to the ones we just used. So in this first example, remember when we have natural log of e to the fourth, when we have a natural log, there's implied base e right here. So the base for the log matches the base for the exponent, so the answer is indeed just the exponent. So in this case, my answer will simply be 4. In the next example, the natural log of the cube root of e, if I rewrite that, that would be the natural log of e to the 1/3. Now that I've rewritten it, the base for my logarithm, which is e, matches the base for my exponent, which is e, so my answer is going to be whatever the exponent is, which is 1/3 in this case. In the next example, I have the natural log of the 5th root of e to the 4th. So if I rewrite this first, let's take it out of radical format and put it in exponential format, meaning, for this part right here, this is the part that I'm going to rewrite. So that would be natural log of e to the 4/5. And if the base for my logarithm matches the base for my exponent, the answer is going to be my exponent, in this case, 4/5. In the last example, we have the natural log of 1 divided by e to the 7th. When we rewrite this one, we're going to rewrite it as natural log of e to the -7. Now, I know we normally don't take things that have positive exponents and make them negative, but in this case, it's going to help us because we have an implied base e as the base for the logarithm, and we have an e for the base of the exponent. And so since those bases match, our answer is going to be our exponent, which is -7 in this case. I mentioned at the beginning of the lesson that I would talk a little bit more about why this works the way it works. And you've got some knowledge of understanding that so far, and you'll have even more knowledge in upcoming lessons and as you practice more and more and get a more in-depth understanding of how logarithms work. So there's definitely more than one way you can look at this, but I want to offer some ways to look at it so that you can know why this works the way it does. So I'm going to go back and use the very first example that we did, which was log of 100. And when we worked it just a few moments ago, we changed this so that the bases match. There's an implied base 10 right here, and obviously there's a base 10 right here. So we rewrote 100 as 10 squared so the bases could match, and our answer was our exponent. So that's using kind of the shortcut, so to speak. But let's go through and look at another way of evaluating this log of 100. If we take the lesson that you had just prior to this one, perhaps you would say, okay, well, I can set that equal to x, and then I can take that equation from log format and write it in exponential format, which you can, keeping in mind there's an implied base 10 right here for this logarithm. So 10 to the x is equal to 100. And then I think you very quickly would get that x is equal to 2. Obviously, our answers match. So that's one way you could think about why that particular problem works the way it does. You could follow this format, and you can see that we indeed get the same answer. And you could certainly approach the problems above in that fashion. I think this offers a little bit more of a shortcut, but you could certainly do them in this approach right here, and you would get the same answer. All right, another thing I'm going to mention is that when we ask you to evaluate log of 100, remember that a logarithm is an exponent. So in theory, this means our base 10 down here, 10 to some power is equal to 100. 10 to some power is equal to 100. What is that power? What is that exponent? It's 2. So that's another way you can just conceptually think through it. What is this saying? This is saying 10 to some exponent is equal to 100. What is the exponent? That exponent is 2. All right, so I did want to offer some explanation on why this works the way it does. I chose to use a method that would follow nicely with what we had talked about in the prior lesson. There are definitely more ways that you could look at this on why it works the way it does, not the least of which is property of logarithms, but that's going to be in an upcoming lesson, so I'll hold off on explaining it via that method. But this follows nicely with what you did in the prior lesson and offers you at least some explanation for why it works the way it does, but you can certainly make use of the rule just straight up as we did in the prior examples. All right, so this wraps up the day 8 video, and this lesson focused on just giving you an introduction to common logarithms and natural logarithms.